Welcome back to Massetti's Math Movies, where it's a cute to be a square. Today's lesson is 10.1, Simplifying Square Roots. By the end of the lesson, you will be able to simplify square roots. Often a square root is called a radical. A radical is an expression with a square root symbol. So for example, 2 square root 5, x square root 3. 32 square root xy. These are all radical expressions because they have a square root in them. The radicand is the expression inside or under the square root. An expression under the square root. So this would be 5 would be the radicand. In this example, 3 would be the radicand. And in this example, xy would be the radicand. So now we're going to start practicing. We're going to do a calculator, and then we're going to do it without our calculator as well. Find the square root of 52. Round your answer to the nearest tenth, then check to make sure your answer is reasonable. All right, so the nearest tenth. So second square root 52, 7.2111. Round to the nearest tenth, that'd be 7.2. Now, does this make sense? Well, I'm going to think of perfect squares that are really close to 52. 49 is a perfect square. It's really close to 52. Right, square root 49 and square root 64. The square root of 49 is 7. The square root of 64 is 8. So this is somewhere between 7 and 8. Yep, 7.2 makes sense. We're between 49 and 64. So the answer has to be between square root 49 and square root 64, or 7 and 8. The answer is between 7 and 8, so it makes sense. 7.2, that makes sense. Use the Pythagorean theorem to find the length of the hypotenuse to the nearest tenth. All right, so we get to round. So a squared plus b squared equals c squared. There's c. A squared plus b squared. Now we learned before that the square and the square root cancel each other out. So c squared equals 2 plus 3, because the square and the square root cancel each other out. So c squared equals 5. Take the square root. C equals the square root of 5. Now that's how I would like to leave the answer. But they said round to the nearest tenth, so we put that in our calculator. We get 2.2, which is approximately 2.2. Multiply the radicals, which is the square roots, then simplify if possible. Simplify means no decimals. That's how a lot of this chapter is going to be, is no decimals. Okay, so square root 3 and square root 7. Well, since these are both underneath the square root, I can multiply them together. So 3 times 7, which is 21. So this is square root 21. Now we can check our answer, but this is it. This is how we're going to leave it. But we can check to make sure that it's right. So I do square root 3 times square root 7 is 4.58. Well, let's see what square root of 21 is. It should be the same thing. That's how I know I did it right. So that's my checking. Same thing here. Square root 2 and square root 8 is square root 16. If those are both underneath the square root, we can multiply them together. And square root of 16 is a perfect square, which is just 4. Not square root 4, just 4. If you don't believe me, put it in your calculator. In example 3, why is it possible to simplify square root 16 but not square root 21? That is because 16 is a perfect square number and 21 is not. All right, here we go. Simplify. Once again, remember simplify means no decimals. So how do we simplify square root 12 with no decimals? Well, there's two different ways. And one way that you probably learned in algebra is to get all the perfect squares out, to get the pairs out. So you take 12 and you break it down. How can 12 break down? Well, 12 breaks down into 2 and 6. 6 breaks down into 2 and 3. Then you circle your pairs. You look at all your bottom numbers and you circle any pairs that you have. 1 from each pair goes to the outside. I'm going to write that down so we don't forget. So 2 goes to the outside, and then whatever's left over stays inside. Leftovers stay inside. So 3 is left over, so it's going to be inside the square root, 2 root 3. All right, so let's see if that was right. I'm going to check. I'm going to put square root 12 in my calculator, 3.46, and I'm going to put this in my calculator and see if it's the same, 2 root 3. Yep, 3.46. That's how I know that I did it right. So, same thing with 45. 45 breaks down into 5 and 9. 9 breaks down into 3 and 3. This is all multiplying. Here's a pair. 1 of each pair goes to the outside. Leftovers stay on the inside. Let's check to make sure that works. Square root 45, 6.7, and 3 root 5. Yep, we did it right. So that's one way. The other way is if you know your perfect squares. So I think over here we should write down our perfect squares, because we're talking a lot about squares and square roots here. So the first perfect square, we don't count 1, but 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, and we'll just stop at 13 squared. Right, these are your perfect squares. They should never be under the square root. So when I see 12, I think of 12 and I try to find a perfect square that goes into 12. Well, I know 4 does. 4 times 3. So I can pull this apart. Square root 4, square root 3. What is the square root of 4? Well, it's 2. 2 root 3. Look, it's the same answer. So this is method number 1 that you can use. This is method number 2 that you can use. So over here, 45, I'm looking for a perfect square that goes into 45. And it's 9. 9 times 5. So I can pull this apart. The square root of 9 is 3. 3 root 5. Notice, same answer. So use whatever method you prefer. This is the factoring tree method. This is the pulling out the perfect square method. Find the square root, round your answer to the nearest tenth. So you're going to do this now. You can use your calculator here. This is simplified. That means no decimals. No decimals. I want you to do this now. No decimals. So no calculator. You cannot just put this in. Alright, so this is like example 1. This is like example 2. And I also want you to do this now. Simplify means no decimals. So do not just put this in your calculator. This is like example 3. This is M Cubed signing out.